Welcome for the brief demonstration of synchro transmitter receiver pair and error detector. So this is the synchro transmitter and this is the receiver. So also we have provided one true RMS AC voltmeter. So we can perform basically I would say 3 experiments. First, study of synchro transmitter, then study of synchro transmitter and receiver, and then study of synchro as a error detector. So these will be the 3 experiments. So before we start performing the experiment, already the pointer of this transmitter is been set such as whenever we adjust this pointer at 0 degree, at that point S1 and S3 will be having a 0 volts or near about 0 volts. So that is the starting point. Whenever if you see any problem between the input and output, if they are not following for transmitter and receiver operation or experiment, make sure whenever without patching this, just switch on the unit, and at that point if you see, connect the multimeter or this meter, this there should be around 0 volts whenever this pointer is at 0. So that is the starting point. So then once that is done, you can start taking the readings such as the angle versus the voltage. So the angle versus the voltage between S1 and S3, S2 and S3 and S1, S2. So that will be the first experiment. So always you will get that at 120 degrees there will be 0 between two other phases, and at 240 degrees there will be 0 between two other phases. So that is how synchro transmitter can be studied. Once that is done, then we recommend to switch off the unit. Then these are the 2 switches. The main switch for this unit is over here, and these are the 2 switches for the rotor supply. So we are providing around 80 volts to the rotor. So this is a switch for the transmitter's rotor, this is a switch for the receiver's rotor. So for transmitter receiver experiment, both the switches should be on. After that you have to patch it from S1 to S2, S1 to S1, S2 to S2 and S3 through S3 to S3. So you have to follow linearly. So I am patching S2 to S2 and then S3 to S3. So right now I am patching S3 to S3. So before I switch on, I am making sure that there is no pointer is not locked. So I am just taking out this knob, and there is a provision given here. If you are going to perform a synchro transmitter receiver experiment, this knob can be just place it like this. So now before I switch on, these rotor supplies are on, and I am also making sure that there is a lesser error between these 2 pointers, otherwise they will wobble whenever I switch on. So I switched it on, and now I can start taking the readings like this. 0 degrees, this is also at 0 degrees, then this is at 30 degrees, this is at 34, 35, whatever it is, this is at 80, this is at 81 or 82. So basically you have to just see that both are following each other, right? Rather receiver is following the transmitter, and if I see 1 or 2% error also in between this, plus or minus 7% is allowed. So right now it is only 2% or 2 degrees error, so it is less than 1%. So this is how the second experiment can be performed. Now once the second experiment is performed, you can perform the third experiment. For that, 2 things you need to do. First you switch off the unit, then switch off the rotor supply of the receiver, then you take out this knob. The knob is given with 1 screw, and take this receiver's pointer at 90 degrees. There is already a special arrangement is provided with a hole as well as a threading inside, and just tightening this. Now I have to tighten it. Just make sure you do it very carefully, because the pointers are acrylic pointers, so you should not break the pointers while tightening it. So this is sufficient. Once that is done, I'll be moving this to 90 degrees, and once that is at 90 degrees, I'll switch on the unit. So I have switched on the unit now. Now once that is done, we are going to perform the experiment as a synchro as a error detector. So this pointer will be, we are able to move, and this is locked, and the rotor supply is off. So we will be getting a error voltage across the rotor of receiver. So with respect to the difference of the angle, so right now the transmitter is at 0 degrees and receiver is permanently locked at 90 degrees. So the difference between these two is a 90 degrees angle. So the output what we get is cos 90. So cos 90 is 0. So we'll be getting a 0 voltage over here. So difference is 90 degrees. So now if I move this at 90 degrees, the difference between two is a 0 degree. So cos 0 is 1. So we'll be getting a maximum voltage over here. So if you want to see the voltage anytime, you can use this onboard voltmeter provided. So I am just patching this voltmeter. This rotor output is being patched now to the, so this is the maximum voltage. What I am getting is 55 degrees. If I move this back to 0 degrees, I am getting a 0 voltage. Similarly, if I move to 180 degrees, the difference between the two is 90 degrees. So cos 90 is 0 again, and now again this is 270. So the difference between two is again 180 degrees. So 180 is again I am getting a minus 1. So basically I will be getting a maximum voltage, but this is out of phase. What I was getting at 90 degrees when both were 90 degrees, this is also a maximum voltage but out of phase. That's why cos 180, that is a minus 1. So according to this we are getting a error voltage over here. So this is how you can perform all three experiments. So make sure that you handle these potentiometers, or rather these knobs very carefully, as they are acrylic pointers, so you should not try to damage that. And also make the connections properly. You can refer the manual also for that. Thank you.